everyone. Myself Prayak Patel, working as an assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now consider the next unit, unit number 8, string matching. Now in today's video lecture, I will discuss about the naive string matching algorithm and Rabin karp string matching algorithm. Now consider the outline for today's video lecture. First is introduction, what is the string matching. Now consider the method. First is naive string matching algorithm and second method is Rabin karp string matching algorithm. Now first consider the introduction of the string matching. Text editing programs frequently need to find all occurrence of a pattern in a text. Means if you want to find the pattern from the given text, you have a one text and one pattern. Then find the pattern from the given text, then consider the string matching or string processing here. Now consider the efficient algorithms for find this or for this problem is called the string matching algorithm. Among its many applications, string matching is highly used in searching for pattern in DNA and internet search engine. So here use the string matching algorithm. Now consider the text as a, or assume the text as a array T1 to n, means given text length consider as a n. So consider the text location from 1 to n. Now consider the pattern. Assume the pattern is an array P1 to n. So length of the pattern consider as a n. So here text consider from 1 to n and pattern consider from 1 to m. Now consider one example, text T1 to 13 means total 13 character in the given text. A B C A B A A B C A B A C. This consider as a text. Now consider the pattern. Here pattern P equal to 1 to 4. So here consider the length of the pattern or array P size consider as a 4, location 1 to 4. So here given pattern like A B A A. Now here you want to find the pattern from the given text. So here both the things are given to you. Now find the pattern one by one. So here consider the next variable as a shift s equal to 0. So here consider s variable initially equal to 0. Here shift consider as a s. So if we not consider any shift of the pattern, initially no pattern is shifted, so consider s equal to 0. When we shift the pattern to right side, then consider the shift value s equal to 1, 2, 3 like this. So here consider initially s equal to 0. We match the pattern with the first 4 character of the text. In this case, here consider A with A, compare A with A, then compare B with B, then compare C with A. But here not match, fine. So consider next process or next shift operation. After the shift operation, consider s equal to 1, then s equal to 2, s equal to 3 like this. Now pattern match at the location this. Means here consider the pattern and text matching process AA, BB, AA and AA. So here consider the after the shift 3 operation, your pattern match with your text. So consider the shift s equal to 3 because here we shift the pattern 3 times. First time we shift, then consider at the B location, second time shift, then consider as C location, and third time shift, then consider at the location A. So this is called the shift operation. Now here pattern and text is matched. So here consider the value of s. What is the value of s? S starting from 0. So here consider 0 less or equal to s less or equal to n minus m. Now what is the n and m? N means length of the text and m means length of the pattern. So here consider the n minus m means text length minus pattern length. Now consider the first algorithm of the string matching technique. First method is naive string matching algorithm. Here naive method is simple straightforward method for the string matching or string processing technique. Now the naive algorithm find all the valid shift using a loop that checks the condition P of 1 to m equal to P of s plus 1 to s plus m. Means pattern location 1 to m compare with the text location s plus 1 to s plus m. Now consider one example for the naive string matching algorithm. So here consider text as a ACA, ABC and pattern as a AAB. Now first consider the s equal to 0 means shift equal to 0. No any shift operation is performed. So we can check the first text with compare with first pattern. So here consider first two location, first text and first pattern. Compare. Here both the location is matched. So consider the next location. So here consider next location as a C and A in text and pattern respectively. So here consider C and A no match. So consider next step as a shift S equal to 1. Here consider S equal to 1 means your pattern shifted one location. So initially your pattern at location 1, but now your pattern at location 2 of your text. So match the C with your pattern first location A. So here consider these two location compare, but not match are there. So consider the next location, and next location means consider shift S equal to 2. So move the two location of your pattern and compare with the text. So here consider the first match as a compare with A. Now next both the A compare with A. Now consider B compare with B. So here B text and pattern match. So your pattern match with the shift S equal to 2. Now this process will repeatedly until the n minus m process step. So here consider the next step as a n minus m step means up to the last step. Consider S equal to 3. So here compare A with A, then compare B with A. Here no match, so consider stop the matching process here. Now n minus m process is done, so stop this process. The pattern matching with shift 2 means we can say that answer of the naive string matching algorithm for the given example is S equal to 2 means your text and pattern match with the 2 shift operation. T1 to m match with the TS plus 1 to S plus m. So here consider your location 3, 4 and 5 match of your text location with your pattern. Now consider the algorithm for the naive string matching method. First name of the algorithm is naive string matching T and P. Here argument consider as a T and P. T means your text and P means your pattern. Now consider the text as a same example here. So T 1 to 6 and pattern 1 to 3. Same example here. Now consider first step of algorithm is n equal to T dot length means length of your text. Second step consider m equal to P dot length means length of your pattern. Now consider the for S equal to 0 to n minus m. We already done this thing in your example. So here consider S from 0 to n minus 1. Perform the operation like if P of 1 to m equal to T of S plus 1 to S plus m. So we can say that print pattern occurs with the shift S. So here consider your pattern match with your particular shift operation is your final answer. So here consider first match is not possible, then consider next one, then consider next one. So here in this third location your pattern is matched. In this case you can find your pattern from the given text. Now complexity of the naive string matching algorithm is big O of n minus m plus 1 into m. Now consider the second method of the string matching algorithm. The second method is Rabin karp string matching algorithm. Now for understanding this example, first we understand here given data in form of digit or number. So here consider the given data in d digit means as a given data is decimal number, then consider the value of d equal to 10 because data consider as a decimal data. Now text equal to 3 1 4 1 5 9 2 6 5 3 5 and pattern P equal to 26. Now next consider the one value of Q. Here consider the Q equal to 11 means here we find the modulo with the Q. So here consider P equal to small p equal to p modulo q. So here consider pattern p equal to 26, q equal to 11. So 26 modulo 11 equal to 4. So your pattern's modulo consider as a 4. Now consider the t of s value denotes the modulo q for the text length m. So here consider for the text, given text is 314159 like this. Now for each and every text, consider the length of your text as a 2 element, because given pattern length equal to 2, because pattern consider as a 26 and length of the 26 consider as a 2 digit number. So consider the 2 digit for your text. So initially consider the first 2 digit as a TS0. For TS0 consider data as a 31 as your data P modulo with the your data Q. So 31 modulo 11, initially we find the modulo with pattern. Then consider for each and every text find the modulo with 11. So here consider TS0 equal to 31 modulo 11 equal to 9. Now consider the next 2 location. Here next 2 location means remove the first element and insert one element from the right side. So consider 1 for as a your next text. So consider TS1 equal to 14 modulo 11. So answer equal to 3. Now consider the next 2 location as a 41. So consider TS2 equal to 41 modulo 11 equal to 8. Now next 2 location consider as a 15. So TS3 equal to 15 modulo 11 equal to 4. Now consider next 2 location as a 59. So find the 59 modulo 11 equal to 4. So TS4 equal to 4. Now same way you can find the next 2 location. Consider the next 2 location of your text and find the modulo with 11. So next is 92 modulo 11 equal to 4. Then next 26 modulo 11 equal to 4. Then 65 modulo 11 equal to 10. Then consider next as a 53 modulo 11 equal to 9. And last 35 modulo 11 equal to 2. So here we consider modulo for each and every 2 character pair. And this modulo consider as a second table 9, 3, 8, 4, 4, 4, 4, 10, 9, 2. So after that consider the your pattern modulo answer equal to 4. And in your text there are many possible modulo answer, but out of this all consider only value of 4 in this modulo table. So your pattern modulo equal to 4. That's why we can say that in given text which answer consider as a 4, it's consider your pattern. So consider or match the pattern with only this 4 location here. Now consider the pattern equal to 26 and small p equal to 4 for the given patterns modulo. Now for the text, here consider this is a text modulo 11 answer is T of S. We already find TS0, TS1, TS2 like this. So this second table consider as a TS table. Now in TS table consider the value 4. So here our equation is if T of S equal to P, then if P of 1 to M equal to T of S plus 1 to S plus M, then consider pattern occurs with the shift S. So here first we compare. T of S means your text modulo answer and P means patterns modulo answer. So here text modulo answer and patterns modulo answer is matched. Then we compare the whole text, means here consider modulo answer equal to 4. Then we check for answer occurs from the 15 or 59 or 92 or 26. So here consider the text matching process after the your modulo answer is matched. And after that, if the whole the text is considered as a same, then consider your text is matched. So here consider modulo for answer equal to for this 4 step or 4 location. Now first location is first for occurs from the location or data 1 5 from the text 1 5. So here consider 1 5 is your pattern. No. So here consider this step is not matched. So consider this step as a next step. But this first 4 is not your pattern. That's why we can say that this for consider as a spurious heap. Now consider the next for value. Next for value find from the location 59. So 59 is your pattern? No, your pattern is 26. So consider this is not your answer, and also this consider as a spurious heap. Now consider the next for value. Next for value occurs from the 92, and 92 is not also your answer. So consider this is also a spurious heap. Now consider the last for value, and last for occurs from the 26. Now match the 26 text with your pattern 26, and here text and pattern matching occurs. So consider this is your final answer or valid match for the your text with pattern 26. Now consider the algorithm for the Rabin karp method. We can compute the T of S using the following formula. T of S plus 1 equal to 10 T of S minus 10 raised to m minus 1 T S plus 1 plus T of S plus m plus 1. Now here consider your text is like this 3141 like this. Now in text first two location consider as a 31, because here length of the pattern equal to 2. So consider only two location of your text. So first is 31. After performing or find the value of the modulo of 31, consider next location as a location 1 for or value 1 for. So for that we consider remove the first element 3 from this list and add the one element 4 at right side. So here consider we wish to remove the higher order digit Ts plus 1 equal to 3 and bring the new lower order digit Ts plus m plus 1 equal to 4. So that's why we perform this operation. So T of S plus 1 equal to, here consider 10 as your value D, then consider T of S equal to 31 minus, consider 10 raised to m minus 1, m equal to 2, so here consider 2 minus 1 equal to 1, so 10 raised to 1 minus 3, consider as your digit. So here after that consider the value plus 4. So here 10 into 1 plus 4 equal to 14. So next value consider as a 14. For the Ts plus 2 also consider the same process, 10 into 14 minus 10 minus 1 plus 1. So final answer equal to 41. So your next two location consider as a 41. Same way you can find the value for each and every element. So we can say that this formula used for find the two element of your text for the matching of or find the modulo for the given data. So here consider first part Ts plus 1 used for the remove the higher order digit from T of S, because here we write T of S minus something. So this part consider as a removing from the part or first digit from the T of S. Now second part is T of S plus m plus 1 used for the bring the lower order digit with your text. Now consider the whole algorithm for the Rabin karp method. Rabin karp matching algorithm is name of the algorithm. Then T, P, D and Q for consider as an argument, T as a text, capital P as a pattern, D means digit, 10th number or 2-digit number like this. So here D consider as your base value. So decimal number consider D equal to 10. Then Q consider as a modulo. Now here consider text is given, pattern equal to 26, D equal to 10 because decimal number, and Q equal to 11. Now consider first step is n equal to length of T. Length of T equal to text length, and m equal to length of P means pattern length. So here consider n equal to 11 and m equal to 2 for our example. Now consider the h equal to D raised to m minus 1 modulo Q for find the your next value. So here consider value of h equal to 10 according to this equation. Now consider the P and T0. P initially 0 and T0 initially 0. Here consider the initial value for P and T0 equal to 0, 0. After that find the new value of P and new value of T0. So here consider P means modulo of your pattern and T0 means initially modulo of your initial text, means first two digit 31 modulo 11. So here P equal to equation dp plus pi modulo q, and t0 equal to dt0 plus t of I modulo q. So here after find the p and t0, new value of p and t0 is 4 and 9. So consider these two value for p and t0. Now consider next loop as a for s equal to 0 to n minus m2, because we perform the operation for n minus 1 step. Now first, if p equal to t of s, then perform the following operation. Here p equal to t of s means pattern modulo match with the text modulo, and if both the modulo are matched, then perform the operation of the pattern matching. So here consider the next step as a if p of 1 to m equal to t of s plus 1 to s plus m, means here for example consider p value equal to 4 and ts value equal to 4, then we consider the both the text and pattern and find the or match the individual element, means 4 occurs from the 15. Then consider the t of s as 15, t of s as 4, and find the whole text as a 15 and compare the 15 with the 26. So this step used for that. Now if the whole text is matched with the pattern, then we can say that the print pattern occurs with the shift s. If pattern is not matched, then we consider the next part. If s less than n minus m, then means pattern is not matched, but your value of s shift operation is less than n minus m, then we perform the last operation t of s plus 1 equal to d ts minus ts plus 1 into h plus ts plus m plus 1 modulo q. This operation is for find the your next two text and find the modulo of this two text. So consider this is your final answer of your Rabin karp string matching algorithm. So in today's video lecture, I will discuss about the two methods for string matching. First one is naive method for string matching, and second one is Rabin karp algorithm for string matching. Thank you for watching.